In this video, I will be showing you how to solve trigonometric equations such as these. Now, along the way, we may need some of these identities. So you should be able to generate this chart from memory. So make sure that if I ask you to take out a sheet of scratch paper and write down the identity chart, you could create this entire chart. Pause the video and study if you have to. You also should know all of these facts by heart as well. Be careful to never divide by a trig function because indirectly you're dividing by 0. Instead, we are going to subtract cosine x from both sides. So that will give us cosine to the third x minus cosine x is equal to 0. Now we have a common factor here, a GCF. So let's take cosine x and pull that outside of parentheses. That will leave us with cosine squared x minus 1 is equal to 0. Now we will set these factors equal to 0. So on the one hand, we will have cosine x is equal to 0. And on the other hand, we will have cosine squared x minus 1 is equal to 0. If I add 1 to both sides, I have cosine squared x is equal to 1. If I take the square root of both sides, I have cosine x is equal to plus or minus 1. Don't forget the plus or minus that you get when you take the square root of both sides. All right, now, where is cosine equal to positive or negative 1? In the back of my brain, I am picturing this. That's supposed to be a circle. We're talking about quadrantal angles. All right, cosine is an x value. So on the far right, over here, cosine has the value of positive 1. And on the far left, cosine has the value of negative 1. So that is going to be 0 and pi. All right, 0 is here and pi is here. By the way, we will call this 0 instead of 2 pi. Now, where is cosine equal to 0? Well, x values will be 0 right on the y-axis. So that will be here and here. So that is going to be pi over 2 and 3 pi over 2. And there you go. So these should be the 4 answers to problem number 1. When I look at problem number 2, I do not like the fact that I have 2 different trig functions here. I have secant and tangent. So I'm going to need my identities. So secant squared is 1 plus tangent squared. So I'm going to make that substitution. So I have that 2 here, so I'm going to have to keep that. So I have 2 times 1 plus tangent squared x. Okay, I made that substitution right there. Plus tangent squared x minus 3 is equal to 0. All right, I might have to make this even finer. I need to do the distributive property. So this will be 2 plus 2 tangent squared x plus tangent squared x minus 3 is equal to 0. Now I'm combining my like terms. So 2 tangent squared x plus 1 tangent squared x. If I put these together, that's going to be 3 tangent squared x. And then I have 2 and negative 3 together, that is negative 1. So adding 1 and dividing by 3, I'm going to get tangent squared x is equal to 1/3. Then if I take the square root of both sides, All right, don't forget your plus or minus whenever you take the square root of both sides. This is going to give me tangent of x is equal to plus or minus 1 over root 3. Okay, now the reference angle is going to be pi over 6. All right, because 1 over root 3. The tangent of pi over 6 is 1 over root 3. Whoops. So I know that the reference angle is pi over 6. Because we want the positive values and the negative values, we want all 4 angles. All right, all 4 quadrants will be good. So you should not have to draw this out the way I'm doing. All right, this is just for instructional purposes. But here's where all the pi, here are multiples of pi over 6. Okay, these are the 4 angles that have a reference angle of pi over 6. And because I want positive ones and negative ones, I'm going to keep all 4. Okay, so this first one right here, that's pi over 6. This one way over here, that's 5 pi over 6. All right, this one right here is 7 pi over 6. And this one right here is 11 pi over 6. So these are the 4 answers to problem number 2. All right, looking at problem number 3, again, do not divide by tangent x. That's a little bit tempting. Instead, I'm going to subtract tangent x from both sides. So that's going to give me 3 tangent cubed x minus tangent x is equal to 0. Now I have a common factor of tangent x. So I'm going to pull a tangent x outside of parentheses. Then inside I'll have 3 tangent squared x minus 1 is equal to 0. So now I will set each of these factors equal to 0. So I will set tangent x equal to 0, and I will set 3 tangent squared x minus 1 equal to 0. If I add 1 and divide by 3, that will give me tangent squared x is equal to 1/3. If I take the square root of both sides, that's going to give me tangent of x is equal to plus or minus 1 over root 3. So, didn't we just deal with this on the previous problem? So, on the previous problem, I saw that the answers would be all 4 quadrants where the reference angle was pi over 6. So it's going to be the same answers again. So once again, I will have pi over 6 and 5 pi over 6 and 7 pi over 6 and 11 pi over 6. Okay, now in addition to that, I need to know where tangent is equal to 0. Now tangent is sine over cosine. So I have sine over cosine is equal to 0. The only way for a fraction to equal 0 is if the numerator is equal to 0. So this means that sine x must equal 0. So I really can disregard the cosine. So where is sine of x equal to 0? So I'm picturing my unit circle. All right, I'm looking at the quadrantal angles. Sine is a y value. Y values are 0 on the x-axis, here and here. So that is 0 and pi. So those are the additional answers. So these are the 6 solutions to the problem. Okay, I do not like the fact that I have 2 different trig functions. So if I look at my identities, I see that sine squared is equal to 1 minus cosine squared. Alright, so I'm going to replace this with 1 minus cosine squared. And then I'll just bring down the rest. Okay, I'm going to subtract 2 from both sides. And I'm going to rewrite this in descending exponential order. So now I will keep the negative cosine squared x in the front, and then my plus 2 cosine x. But 1 minus 2, that's negative 1. I will put that at the end. I do not like the fact that my leading coefficient is negative. So I'm going to multiply both sides of this equation by negative 1. Okay, if I multiply both sides of the equation by negative 1, that's just going to change all the signs over here. So that's going to give me positive cosine squared x minus 2 cosine x plus 1. 0 times negative 1 is still 0. So I have this. Now I need to factor this trinomial. Alright, I use the Burton Method, which involves a little bit of common sense and a little bit of guess and check. So cosine squared. Start with that. Cosine squared. What times what will give you cosine squared? Well, that would have to be cosine x times cosine x. Alright, next I jump over to the last term. What times what will give me 1? Well, that would have to be 1 times 1. And then finally, I say to myself, inner plus outer must equal the middle. Inner plus outer equals middle. Inner, I have 1 cosine x. I'm multiplying these. Outer, I again have 1 cosine x. I am multiplying these. I can control whether or not they are positive or negative. In order to come up with negative 2, both of these would have to be negative, which means that both of these would have to be negative. Check one last thing. Does negative 1 times negative 1 equal positive 1? Yes. So that means we factored correctly. So we will set each factor equal to 0. So cosine x minus 1 is equal to 0. Normally I would set this equal to 0 as well, but it's the exact same thing. So here I have cosine x is equal to 1. So where is cosine equal to 1? That is at 0, actually. So 0 is my only solution. And in my mind just then, I was picturing the quadrantal angles. Alright, cosine is an x value. Alright, x values will be 1 on the far right only, and that is 0. And we're going to call it 0, not 2 pi. Alright, I like the fact that both of these are secant. So I'm going to go straight to the part where I subtract 2 from both sides. So that's going to give me secant squared x minus secant x minus 2 is equal to 0. Now I can go ahead and begin factoring this. Secant squared can only be secant times secant. Ignore the negative sign for a minute. I see the number 2. There's only one way to get 2, and that's by doing 1 times 2. Now inner plus outer must equal the middle. Inner, I have 1 secant x. Outer, if I multiply these, I have 2 secant x. I'm trying to get a middle of -1. So if this was a +1 and this was a -2, that would make -1 secant x. Alright, but if this is positive, that means that this number is positive, and if the outer is to be negative, then this 2 has to be negative. Check one last thing. Does +1 times -2 equal -2? Yes. So now I will set the factors equal to 0. So I will set secant x plus 1 equal to 0. And I will set secant x minus 2 equal to 0. So here I will have secant x is equal to -1. Now I'm more comfortable with the reciprocal trig function. Secant is the reciprocal of cosine. So if I take the reciprocal of both sides of the equation, I'm going to get cosine x is equal to -1. The reciprocal of -1 is still -1. Similarly, if I'll add 2 to both sides, so that's going to give me secant x is equal to 2. And then if I do the reciprocal of both sides, I will have the cosine of x is equal to 1/2. So now I just need to answer each one of these questions. This is going to be a quadrantal angle. So this is going to give me x values are -1. All right, in my mind I'm picturing this. X values will be -1 on the far left. So that's why I'm going to write down pi. Now, where is cosine equal to 1/2? So first of all, the reference angle, the cosine of pi over 3 is 1/2. So that tells me that the reference angle is pi over 3. So in my mind, here's what I'm picturing. As soon as my eraser comes up. Because the reference angle is pi over 3, okay, I'm not going to draw them all. I'm just going to draw this. So thinking of pi over 3's, over here, pi is the same thing as 3 pi over 3, and 2 pi is the same thing as 6 pi over 3. Okay, so let's see. We want cosine to be positive 1/2. So that means we want angles that are on the right-hand side of the circle. So I want this and I want this. All right? Above and below the x-axis, but on the right-hand side where cosine is positive. Okay? Of course, this first one is simply pi over 3 because that's the reference angle. So, you know what? Let me switch to green because it's kind of coming from here. So I will have pi over 3. But then the other one is 1 short of 6 pi over 3. So that means 5 pi over 3. So these will be the 3 answers to problem number 5. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.